Alright, let's do some exam papers. This is part C from an OCR Gateway paper. You can see it below. Go try everything before you watch this video so that you learn more effectively. We've done part A and B before, and you can find those on the channel. And the first part gives you the specific heat capacity and the specific latent heat of vaporization of ethanol and water. And the first part says the specific latent heat of vaporization is the energy transferred when 1 kg of a substance changes from liquid to gas. And when something changes from liquid to gas, that's evaporating. And if you want to, you could also say vaporizing. Okay? And it wants you to calculate the amount of energy needed to evaporate 0.2 kilograms of ethanol. You use the table to do that and some sort of equation to help you. So this is a calculation question. All you have to do is put the numbers together to get the right answer. So you should be able to write something down. Okay? Honestly, if you think about it for a bit, the question tells you the amount of energy needed to evaporate 1 kilogram of a substance. And that's right there. That's the specific latent heat of vaporization. You can find it in the table. So that means that the energy to evaporate 1 kg is going to be 846,000 joules. Now, that doesn't help us answer the question directly, but if you think about it, maybe the energy to evaporate 2 kg, well, you need twice as much energy, so that's 2 times 846,000. It would give you 1,692,000 joules. And so you might as well say the energy to evaporate 0.2 kilograms of ethanol, which is what they want in the question, should be 0.2 times 846,000. And that would give you 169,200 joules. That's right. You would get 1 mark for that calculation there, and 1 mark for writing down the correct answer. Now, what's actually going on? What does any of this mean? So, I'm going to use a particle model in which I imagine the molecules that make up ethanol are small, hard balls. And when ethanol is a liquid, there are intermolecular forces holding the particles together. I've represented them here with these lines, but in reality they're invisible. Sometimes they're called bonds. Now, to turn this into a gas, we need to give the particles energy, which I'm keeping track of there. And so you heat up the liquid and the particles speed up and increase their energy. They are now able to overcome those intermolecular forces. The bonds are broken. This is now a gas. It has evaporated or been vaporized. And the amount of energy you use to evaporate exactly 1 kilogram of ethanol is the specific latent heat of vaporization of ethanol. But different substances will take different amounts of energy to evaporate, depending on how strong the intermolecular forces are between the particles. And that's what the specific latent heat of vaporization measures. How much energy you need to overcome the intermolecular forces for 1 kg of a substance. And so different substances have different specific latent heat of vaporization. Depending on how strong those intermolecular forces are, it will take more or less energy to overcome them. Water has stronger intermolecular forces, so it takes about 3 times more energy to evaporate 1 kilogram of it. So the formula for the energy will be mass, how much kilograms of ethanol you have, times the specific latent heat of vaporization, the amount of energy you need to evaporate 1 kg of it. Easy. So the second part of the question said the energy needed to heat 1 kilogram of water by 1 degree Celsius is 4,200 joules. The energy needed to evaporate 1 kilogram of water is 2,256,000 joules. This is much more than 4,200 joules. Explain why. So really think about it. Try it now. So this question is nice because if you look at the table and then to the question, you can see that it actually tells you the definition of the specific heat capacity and the specific latent heat of vaporization. So pause now if you still haven't got an answer and really think about the bond, the intermolecular forces that hold molecules of water together. Now, stay with me. I'm going to increase the temperature of this water by 1 degree. And that energy goes to the particles, which you can see speed up. Now, the intermolecular forces have weakened, but they're still there holding the particles together. The bonds aren't broken. But if I want to evaporate the water, I have to use a lot more energy. The reason why is evaporating the water requires the intermolecular forces to be completely overcome. Then we can say the bonds are broken and it's a gas. But that takes a huge amount of energy. So, why in heating up water by 1 degree so much less energy? To respond to this question, you can say heating up liquid water by 1 degree only requiring molecules move faster. But, on the other hand, to evaporate water, lots of energy, is needed to overcome those intermolecular forces that hold the particles together, that keep them a liquid. Now, instead of saying overcome intermolecular forces, you can also say to break the bond. Okay, those imaginary little lines that I drew in those simulations. And that's this. 2 full marks there for this statement and this statement.